Welcome back, everybody. Let's now go over the solutions for the homework assignment from the previous lecture. All right, so here we are. We first had the line class, so let's start with that one. Remember that we're taking in these coordinates as tuples. So there's lots of different ways you could have done this. One way is to create the two coordinates as attributes. So we could say self.coordinate1 is equal to the coordinate 1 that's passed in, and then self.coordinate2 is equal to that second coordinate that's passed in. So this is one way to do it. And then later on, what you do is just tuple unpacking to grab the individual components of these tuples. So for example, in the distance formula, we know the distance formula at the end of the day should look something like this. It should be x2 minus x1 to the power of 2. And then we'll say plus y2 minus y1 to the power of 2, and then this whole thing squared. So one way to do that is just to the power of 0.5. So that's one way to take the distance formula, and in order to get x2 and x1, what we could have done is just tuple unpacking here. I could have said x1, y1 is equal to self dot coordinate 1, and then x2, y2 is equal to self dot coordinate 2. So you could have done it this way. The other approach you could have taken is just right off the bat, when you actually create attributes, is create an attribute for each of these. So you could say self.x1 is equal to coordinate 1, and then maybe use some indexing here. It's really up to you what approach you want to take. The main idea being that eventually you have to realize you need to somehow extract the actual components of that tuple, either through indexing or through tuple unpacking. And this is something that I wanted you to get practice with because often you're not going to just pass in single variables into your argument calls. They may be something like a list or a tuple, so you should have classes that are able to work with that. Finally, let's have the slope equation. And we can just copy and paste these lines from up here. And then for the slope, we just return rise over run. So rise is y2 minus y1, and then we're going to divide that by x2 minus x1. We'll run that, and then let's check this out. So we'll say C1 is equal to 3, 2 coordinate, C2 is equal to 8, 10 coordinate. I'll create my line object and pass in C1 and C2 here. And now I'll check out the method calls. We'll say distance, open close parentheses, because we execute that. And that looks like it matches up. And then we say my line, check the slope, and looks like that matches up as well. If you're getting different numbers for distance and slope, given these two coordinates, double check your actual equations here. You may have mixed up x1 and x2, or y2 and y1. So keep that in mind. These should be the results you get for distance and slope given these coordinates. So definitely check your math if you're not getting those same results. It's really easy to make a typo here or use parentheses in the wrong way. So just keep that in mind as you continue. Now we're going to move along to this cylinder class. So as I mentioned when we were going over the homework, this one's actually a little simpler than that line class. So here we have height and radius. Notice they have default height and radius. What I'm going to do is make those both attributes straight up since they're integers being passed in. So self.height attribute is equal to height, and then the instance's radius is going to be equal to the radius that is passed in. And then we're going to just return the volume equation. The volume for a cylinder, you could have Googled this. It's basically just height times pi. We could have also done a class object attribute there, but I'll just pass in 3.14. And then it's going to be the radius. So self.radius to the power of 2. And notice here how I'm using self.height and self.radius inside these method calls because I need to reference the instance of the object's own height and own radius. I can't just reference height and radius by itself. I need that self parameter. Then for surface area, this one's a little more complicated of a formula. Basically, you have the top and bottom of the cylinder, which is pi r squared. So I'm going to say that the top of the cylinder is pi r squared, so self radius to the power of 2. There's a top and bottom, so for the whole surface area, I'm going to return 2 times top, 1 for the top, 1 for the bottom, and then plus the rest of the formula, which is 2 times pi times self.radius times self.height. And the formula is basically just grabbing that middle section of the cylinder and then flattening it out so you actually get a rectangle. Okay, so that's surface area. Let's run this and make sure that our results match up. So I'll say my cylinder or my cyl, call the cylinder right here 2, 3. We'll say c.volume. And it looks like I have an error, name C, whoops, my cylinder, not C. 56.52, perfect. And let's check out my cylinder surface area. Run that, and we have 94.2. Okay, so this should have been pretty straightforward, especially because it's very similar to the circle class. If you're having any issues on this, or there's something that's confusing to you as far as creating these methods, please post to the Q&A forums, and we're happy to give further explanation. I'm going to give a quick overview of what we just did here. So let's start with the line class. First thing we have to realize is that these coordinates are being passed in as tuples, and you have various options of how you want to work with these here. Either you can do the unpacking in your actual attributes, so then you can have self.x1, self.x2, and so on, or once you assign these coordinates, you can do the unpacking in the methods themselves. Again, totally up to you. Then just make sure that you're applying these equations correctly for both distance and slope. For the cylinder, it's a very similar thing. We assign the attributes height and radius, and then we just return back the actual mathematical formulas for volume and surface area of a cylinder. All right, thanks everyone. Again, if you have any questions, post to the Q&A forums, and we're happy to help you out there. We'll see you at the next lecture.